There are three parts to the plasma energy cycle. There's the spin up to the plasma state. There's the plasma energy burst. And then there's the plasma energy collapse. And it all happens in that order. You've seen the plasma energy cycle your whole life. What is it? Well, when lightning strikes, it causes the plasma energy cycle, and a result of that is thunder. There is a high pressure movement around lightning. If lightning strikes a tree, and you see the tree, part of it just shatters right where the lightning goes, that's part of the plasma energy cycle. A big movement that's caused right by lightning. If lightning strikes a big brick building and the bricks fly everywhere, that's a part of the plasma energy cycle. There's a high pressure movement that happens because of that. Now, that high pressure movement can be used to run an engine. Joe Papp discovered it, and Joe Papp used it to build a motor. Joe Papp took one of the greatest discoveries in the history of mankind, and he hired two guys that were raised in a machine shop, Bob and Tom Rohner, and hired them to build an engine. And they did. It was successful. It would produce over 100 horsepower and run for hours. And it needed no external source of energy. Unfortunately, Joe Papp died, and he never revealed the secret to how it worked. Well, many years later, with a lot of work, Bob and Tom Rohner rediscovered the secret. Tragically, Tom Rohner died. The only person left carrying on the work is Bob Rohner. I'm Rohner-Roberts, the author of Particle Mechanics, the Theory of Energy States. When I found out about the discovery that Papp had, the noble gas engine, I took the models that I use in my physics, the noble gases, and when I turned them to the plasma state, I could predict exactly what would happen with the plasma energy cycle. The spin up, the plasma energy burst, and the plasma energy collapse. So I had to go see if what Bob Rohner had was real. So he went to a shop and he let us film what he had. And it was real. And we're going to show you that video, plus we're going to show the physics behind the plasma energy cycle. I'm Rohner-Roberts. This is Bob Rohner. Bob Rohner worked with Joe Papp in the 70s and 80s and built an engine that ran on noble gases. Joe Papp died, and Bob is carrying on the work, and I'm very excited about it because I actually think this is one of the greatest inventions in the history of the world. So what we have here is, this is Bob, and he's going to explain, this is his device that he uses to test the what we're going to call the plasma energy cycle. If you want to explain what you got here, Bob?
I thought you already explained it. I don't have to do it over again. First, I'd like to point out that all this stuff here was Bob and Tom. Not just Bob, that my brother Tom was heavily involved in this too, and spent a lot of time with Papp and with me getting the controls right. What else should I say? One more?
Well,
this is a very simplified method of doing the testing on the cylinders. We basically just use a normal air cylinder that's been machined to match the output of the original Papp engine. We found out through our processes about half of what Papp said was correct, and about the other half was pretty much malarkey, which is not unusual for inventors. They all try to keep it a secret for as long as they can. We have a driving coil around this that's a chamber down below, an air cylinder up above, and a pressurizer on the top. And I think that's up to
So what we're going to do here,
you.
I'm going to show what we're going to do here. We're going to show you the control panel, and we're going to take it all the way apart, okay? And then after we take it apart, we're going to assemble the whole thing and show it running. This just to show you how real this thing is. So now we're going to look at some of the control centers here.
Okay, this entire electronic mess you see around here is my creation. Most of this stuff can be replaced by a circuit board about that big with solid state electronics. But when you're doing experimental work like this, I like to use the most robust types of equipment I can, and mechanical relays are much more robust than electronics. I use an automatic kill switch up here because I have a bad tendency to electrocute myself quite often. So I have a kill switch up here that will kill everything. It kills all the voltages and everything. I have a control panel here that does the charging and igniting. And switches on the voltage. Back there are the capacitors, discharging relays, fusing. And of course, we've got a motor up here, I think we explained otherwise, that keeps track of the waste electricity.
All right, what we have here, this is Bob Rohner's test cylinder. He is testing the plasma energy cycle. Now, if you look at this, these are wires, these are electrodes. This is an electrode, that's an electrode, electric wire hooked all the way around here. There are no tubes. There are no special things that go into this. All right, what he has is he has a cylinder here, and he has 4 objects in it. One of them he calls a bucket, which is basically an aluminum tube. This one right here, it contains thorium and rubidium. The other one contains thorium and red phosphorus. This is the same stuff that Pap used in his patent. And then we have 2 tungsten electrodes in the middle. And there is a gap in here. Now, one of the things is you're going to say, well, is there any tubes going in? Well, you could look here from the bottom. Yeah, they got some legs here. So we're going to go underneath here and look at the legs. Bob's test cylinder here, one of the things he has is he has a little mirror under here that you can see a flash underneath. There are 4 support legs. Behind the support legs, up over here, there is a tube about 4 inches behind. We'll explain that a little later, how you get the pressure and how you measure the pressure. Now come over here, come on underneath here, and as you look underneath here, you will notice just 4 regular old bolts bolted in to his workbench, and you got a tube hooked here. The tube is how we will measure the output of the cylinder later on. Now, the electricity behind this and how to charge this, that's the secret that Bob knows. So what happens is when they charge it, there's going to be an electrical arc that's going to cross there at the right voltage, right electricity, whatever, I don't know, but it's going to cause the plasma energy burst. Once you get the plasma energy burst, we're going to get an expansion. So now we're going to have Bob, he's going to assemble this all back together, and we're going to show it how simple this thing is. All right, this is the cylinder and the piston that Bob is going to use in his test here. This is just a regular cylinder, moves back and forth, just a regular block, nothing fancy. He's going to screw this on with the bolts to do the demonstration. This is a coil here. This is part of the secret. I don't understand how it works, but it's pretty heavy, and as you can see, it's just wrapped copper wire with two wires off the end that you can hook onto. So Bob's going to put that right on there and put the cylinder in between the two. This is real time. I never left the shop for the whole time we were there.
Okay. So, okay so far? Should I keep going?
Yeah.
Alrighty. Now we're going to, first we're going to vacuum it, then we're going to fuel it.
So to get this to work, you have to vacuum out the cylinder. So that's what Bob's going to do is vacuum it out first. That's what he's doing here.
What you hear start up is our vacuum pump. It comes up on this tube. I will turn this on. Back in the back here, I've got a vacuum gauge just to make sure everything's holding the way it should.
That's what this is. This is a vacuum gauge here. So you can kind of tell what's going on.
Now look to see that it's holding the vacuum like it should. And then we will gas it up a little bit.
Now what are you putting in now?
This is the gas mixture.
This is inert gas. These are the Nobel gases.
Okay, I put in enough to raise it up a little bit.
Did you see the cylinder raise up there? Okay.
You had that right.
Uh-huh.
We'll shut her back down again, and we're all done with this part. She's gassed up. Now what we want to do is we're going to vent this back down to atmospheric pressure, maybe just slightly positive. Okay, I'm about 1/10 to the plus side.
So if you didn't catch what Bob did, he vacuumed it out, blew the cylinder all the way full, then he vented some of the gas out and he pushed it down to just slightly above atmospheric pressure. So Bob's getting ready to fire up and show us what to do. He's turned his electricity on now. He's hooked up the two wires. I've witnessed all this. It's all done here continuously.
Okay, I've got a little control box here. What I will do is quickly charge the capacitors, then we'll just fire a single pulse.
Now, did you see what happened there? All right, this thing pulsed. If this was a normal explosion, like if we had charged this up like in a regular engine, it would have blown the top off this thing. It would have hit very hard. So one of the things you got to notice here is this happens fast. We're getting the plasma energy pulse, which is causing the explosion, and then we're getting the collapse. And that's why it doesn't blow through the top of the cylinder. So he's going to do it a couple more times here. Now, Bob can do this hundreds and hundreds of times. It doesn't get hot. If you do it 500 times, there's a little bit of electricity, maybe 2 degrees in the cylinder is the most he's seen. So there is no heat gain in this process. This is all an expansion and a collapse without any heat.
Now I'm going to show you what this cylinder does. This cylinder is basically just put on top to serve as a return. Since I'm slightly positive on my gases, the cylinder doesn't want to quite return all the way down. So this serves both to cycle the cylinder completely down and to allow me to measure the output force. And I do that by determining the length of travel and the amount of pressure in the cylinder. That gives me the increase in potential energy and allows me to calculate the input and output of the entire system.
So in more of my layman's terms, it helps push the cylinder back down, and it also has pressure associated with it. So it's more work. Bob can calculate how much work it is. That's what this tube is, okay? Like we saw it underneath, this is not something that's powering the engine. Just 4 rods, you just run the bolts on there. You saw how it attached here, it just touches the top of those bolts.
Okay, this cylinder is a 2-inch cylinder. So pi r squared is 1 times pi. So we have about 3 square inches on this cylinder. We're sitting at 120 psi. So 3 times 120 is there's roughly 360 pounds of force pushing against the cylinder when I fire it. So roughly me and a half sitting on top of here. That's what this has got right here. There's no
400 pounds. It's like he's lifting 400 pounds. So watch this.
Now, let's see. Am I forgetting anything? Don't think so. Oh, I use a little rubber O-ring, and you'll see it later, to keep track of the amount of stroke, so I can calculate the potential energy. So,
Now, if you notice this ring here, that was the travel that he got.
so by using that ring, see, I've got 1 3/4 inch travel. I know that it's 360 pounds. So that's all you need to know to be able to calculate the energy output of the system. The energy input, of course, is a function of the drop in voltage and the capacitance. So here we go. We'll do it a few more times.
As you can see, this is a repeatable process. No heat, no gases, nothing but electricity going in, driving that 300 or 400 pounds up time after time after time.
They can see that in the video. Should point out this. Back in the back here, this little electric motor with the fancy little stripes is connected to this capacitor. And this capacitor is connected to the anode and cathode up here on the engine. And after the plasma fires, during the collapse, a strange electrical impulse is put out to the capacitor. I have the motor hooked to the capacitor because it will discharge the capacitor, and it demonstrates that, yes, we have some waste electricity in there that can be utilized to fire the other cylinder. So if you can see that back there, and I think you can see that I am
See that motor spinning?
producing a large amount of waste energy at the same time that we're firing it up here. Strangely enough, too, this waste energy has nothing to do with the input and output measurable energy or the potential energy and the electrical energy I'm putting in. So it's either a summation to the output or a subtraction from the input.
So not only are we getting usable energy that you can use to drive things or work with, we're also getting excess electricity. So this plasma energy cycle, guys, is going to go down as one of the greatest inventions in history. All right, as you can see this is a pressure gauge. This is this hose that goes down in the back. All right, this pressurizes this cylinder here. We showed it in the video there. It's got 120 pounds of pressure on it. So this is the cylinder that pushes against, and this is how Bob calculates the amount of work that he was able to get whenever he gets the plasma energy burst. You can see it all here, and you can kind of figure it out, and it moves that. So we're just showing a little better angle of that. All right, what we got here is at the bottom of this test piston, there's a little glass opening, Pyrex. And what Bob has got is there's a little mirror that's underneath there that shows the flash. So what we're going to do is see the flash, and you can see the electrical and light, it comes out of this. whenever you do the plasma energy cycle. So Bob, if you want to fire it up here. See that? Very bright flash. Like a flash cube, very bright. Cool stuff. I mean, just beyond belief, isn't it? This is the original PAP motor that Bob Rohner did the machining on. Tom Rohner built the controls and did a lot of the electrical. They had this running for many years. Since Joe Papp died, it's been disassembled, taken apart, and moved to different spaces, and obviously it's not in working condition anymore. Bob, how many times did you see this run?
Well, between Tom and myself, we probably saw it running at least 20 different times. I'd say the longest time that I watched it run was for about 8 hours.
And the horsepower readings you had off the dynamometer was?
The highest that we saw was 107 horse, the same as the certification numbers that the University of Oklahoma came up with.
So 2-cylinder engine, there it is. And we saw this, Bob is able to reproduce this in a piston. We just saw that. So it's real. The plasma energy cycle is real. You saw it. It moved 400 pounds, 1.75 inches, and there was some residual power left over. You should be able to figure out what you can do with that in the motor. Now, why am I involved? Because I'm going to explain the physics for this. They're very simple if you use the keyring atom. And we're going to come over here and we're going to show it to you. Alright, there's 3 parts to a plasma energy cycle. Spin up, plasma energy burst, and the plasma energy collapse. Now, one of the things that we're going to show you is a top, and we're going to spin it. We're going to do a spin up. Now, these things are set solid. It's a C-shaped. So remember this C-shape. Watch what happens. Alright, this is the top, and this is a spin up. This is a collision, collapse. That was the plasma energy burst. Did you see it jump away at high speed, and then it slowed down and stopped? That's the plasma energy collapse. And if you can understand that, you're going to be able to understand how this works in physics. If you followed my theory, this is the keyring atom, redesigned atom, not the standard model. Proton ring, 1 ring in the center, holds thousands of particles. Now, when an atom gets cold, the electron rings that go around the outside spin slower. This would be a very, very cold atom. This would be a cold atom. This would be a warm atom, because the size of them and as the speed of these goes faster, the rings get bigger. And then this one here would be a very hot one, and at this point, when the rings start to open up, it goes to the plasma state. And it's all because they spin faster. So now, in the noble gas engine plasma energy cycle, we're going to show you how this happens. Now, this is neon, a noble gas. Now, the proton ring configuration is a C20. There's 20 proton rings that go around the center of it. Now, this one would be a cold neon. So, just like when we charge the top up, something has to spin up the particles on the outside, the electron rings. Now, they use thorium inside there and electrical charge. Thorium gives off alpha particles. Now, if you followed my theory, this would be a helium particle, or an alpha particle would be a helium with no electron rings. So now if you excite those, which is what the secret is, I don't know how they do it, but it's the secret inside of the PAP engine, and inside of Bob Rohner test piston, and the plasma energy cycle. When the alpha particle comes by, they're going to be traveling about 1/20th the speed of light, as it comes by, if it hits one of these outside rings, these electron rings, what's it going to cause it to do? As it comes by, it hits it, it's going to cause it to speed up, right? So what happens when it speeds up? It's going to go from a round shape to a C shape. Now, this is a neon atom that's been hit at high speed with lots of particles. So now you have all these C shapes that are spinning at 1/20th the speed of light. What happens when the C shape hits another atom? Bang! It's going to blow apart, and it's going to produce the plasma energy burst. Remember, the C shape is a rigid particle against a particle that has matter, or against a piece of this element that has inertia. It has a mass that's hitting another one, and it's going to knock them apart. And just like that top, boom, that was a burst. After it hits, the particles are either going to go off and form electricity, or they're going to slow down and they're going to be much smaller back to a cool atom. That's why there's no heat in this process. You are skipping what would normally have to be to heat an atom up. You would just slowly, the electron rings would slowly get bigger as it gets hotter. In this, you don't. You have a violent hit with this, and it takes it right past, heating it up, takes it to the plasma state, spins it up, hits the other elements, bounces apart, collapses, and goes back to zero, and there's no heat involved. It's that easy. Now, one of the things, remember, you need to go look at some of my other videos. I have several videos on the hot and cold and the keyring atom. When they're small like this, they're solid. When they're like this, they're going to be a liquid. When they get bigger like this, they're gassy, they're bouncy. And then when they get like this, they turn to the plasma state. And in that, they're going to get very violent reactions. Strange things are going to happen when they get to the plasma state. But I've got other videos. You may want to go watch them if you're not versed in the keyring atom. And a normal gas, round, spinning. Gases are going to bounce around, round top. Also have the C-shaped. Now, when we spin this round one, it bounces. These gases are going to bounce off of each other. You add in a plasma energy burst, you get a massive increase in pressure. That's it. That's what's happening inside with a plasma energy burst. A spin up, a burst, and a collapse. This is a standard model of neon. 10 protons, 10 neutrons, 10 electrons all orbiting around. If you're going to use this to explain the plasma energy cycle, good luck. Because the plasma energy cycle definitely violates the 20th century laws of physics. However, when you use the keyring atom with 21st century laws of physics, it easily works and it predicts it. Why is that? It's because physics and chemistry are easy with the correct geometry.